Welcome to the EYU 2020 and to our booth, Why Hawaii is a Volcano. We are the Tracking laGrangian Buoyancy Lab, or KGB Lab in UCLA, and we study the processes in the Earth's interior and their link to surface manifestation. This intro video will guide you through the content of our booth and in particular our YouTube list. Hawaii is in the middle of Pacific, and this is what it looks like from the space. We can also see the Hawaiian seamount chain, and actually from southeast to northwest, those volcanoes are progressively older. So why is that? To answer this question, we first need to know the layer structure of our planet. From the surface to the center of the Earth, we have crust, mantle, and outer plus inner core. The topmost mantle and crust together constitute so-called plates. The temperature of the core is very high and uneven. It heats the mantle and leads to hot rising plume, with mushroom-like head and thin tail. When the plume reaches the plate, it will hit the surface and create a volcano. If there is a relative movement between the plume and the plate, we will get a volcanic chain, and the latest volcano is called hotspot. And this is the case for Hawaii. The plume is relatively fixed, while the plate is moving from southeast to northwest. Here is from right to the left. And as a result, Hawaii is the youngest volcano in this chain. If you want to know more about why Hawaii is a volcano, you can check the second video in our YouTube list. So a good news is mantle behaves like viscous liquid over a long time scale. Thus, we can create our own mantle plume with Carolite syrup, a clear tank, and a heating pad. We can just heat the tank with syrup and get our plume. But it's better to have a temperature controller, since we don't want to overheat the tank. Usually 140 degrees Fahrenheit is sufficient. There are basically two ways to show a plume. One is Shadowgraph, and the other is to use various tracing particles. For the Shadowgraph, you will need a flashlight and a projection plane, like the wall. Light goes through the syrup, and you will see the shadow of the plume on the wall. The principle is hotter syrup has less reflective index, and light bends based on the reflective index. Alternatively, you can also stick a tracing paper just behind the tank and see from the other side. In video 3 and 4 of our list, we will show you how to get your Shadowgraph at home with wall or tracing paper. And in video 5 to 7, we will show you how to record a Shadowgraph time-lapse using syrup and water, and the importance of using clear syrup. As for the second method, we want to show two tracing particles. One is food dye, which is straightforward, and the other is thermochromic liquid crystal, which can be used to make the forehead thermometer because it changes color with temperature. In video 8, we will show you a 3D view of plumes with food dye. And in video 9, we will show you a 2D view of plumes with TLC. We hope you can enjoy our video and create your own plumes. We also have a live session from 2 to 3 p.m. To know more about us, please visit our website or simply click Learn More in our hopping booth description. Thank you.